deciles and percentiles. Like in quartiles, we used to divide the observations as 25%, 50%, or I can say in quarters, first quarter, then second quarter, then third quarter, like that. In deciles, you divide the entire observations in 1/10, first 10% of observations, then first 20% of observations, then first 30% of observations, like that. Then you try to find out the central value, that is decile. Percentile, it is about uh, this is 1/10, this will be 1/100th. That is the difference. Let me write directly the formula for decile and percentile as di. What is di? It is the ith decile. Is 1 by 10 times, or I should say I by 10 times n plus 1th value after arranging the observations in ascending order, where this I will range from 1, 2, 3 up to 9. Whereas in quartiles, if I write it generally, like instead of writing Q1, Q2, Q3, I can also write it as QI. QI is, I can say, I by 4 n plus 1th value. So if I write here, I is ranging from 1, 2, and 3. If I write I as 1, here also 1 will come. You will get this formula. If I put I as 2, 2 by 4. 2 by 4 is nothing but 1 by 2. I will get the median formula. If I put I as 3, 3 by 4 times n plus 1th value, I will get this third quartile formula. That is what we try to do. So here you are writing it in general like this. This is the formula to calculate decile. Now next one is percentile. So I can say PI is ith percentile. Ith percentile. How do we calculate ith percentile? It is I divided by 100 times n plus 1th value, where after arranging the observations, in ascending order. Here I ranges from, just a minute, sorry. Here I ranges from 1, 2, and so on up to 99. So quartile is up to 3, decile is up to 9, percentile is up to 99. So with this understanding, we will now move on to solve some problems. Right. What is the value of the third decile for the numbers 15, 10, 20, 25, 18, 11, 9, 12? So first of all, let me arrange the observations in order, arranging in ascending order. We get first number is 9. Then 10, then 11, 12, 11, 12, then 15, 18, then 20, 25. So how many observations? 8 observations. So I say here n is 8. We are interested in third decile, D3. So I by 3. What is I? 3. 3 by I by 3, not I by 3, I by 10. So 3 by 10 times n plus 1th value, which is 3 by 10 times 8 plus 1th value, 9 value, or 27 by 10, which is 2.7th value. So straight away I can split this 2.7 into 2. One is 2, another one is 0.7. So that means this is second value plus that 0.7 times. Since I wrote second here, I'll have to write third, the next one, minus same second. What is second value after arranging? 10. What is the third value? 11 minus 10. So this is 1. 1 into 0.7 is 0.7. 0.7 plus 10 is 10.7. So the result for third decile is 10.7. The next question. The average salary of a group of unskilled workers is rupees 10,000, and that of a group of skilled workers is 15,000. If the combined salary is 12,000, then what is the percentage of skilled workers? Here, there are two groups. One is skilled and unskilled. So I'll write first unskilled, then skilled. They gave us average. So I'll say mean salary. Unskilled, they gave us 10,000. Skilled, they gave us 15,000. Then this will be a combined one. Combined means skilled and unskilled together. That they gave us 12,000. We don't know how many people. So I'll say number of observations. I'll consider unskilled as N1, skilled as N2. So combined will be N1 plus N2. Right. Now, what is the question? What is the percentage of skilled workers? Percentage of skilled workers. How do I calculate percentage of skilled workers? I need to know how many skilled workers are there. We are assuming it as N2. Okay. Total number of workers is N1 plus N2. And then multiply by 100, I will get this percentage of skilled workers. Means how many skilled workers divided by total number of workers multiply by 100 will give you this result. Now, we have got combined arithmetic mean, unskilled arithmetic mean, skilled arithmetic mean. Let me call this as x1 bar, this as x2 bar. Since this is combined, I'll call it as x bar. Now, what is the formula for combined arithmetic mean? We know it is, we know it is x bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So I can rewrite this as 12,000 is equal to n1. We don't know what is n1, but we know x1 bar is 10,000 times n1 plus x2 bar is 15,000 times n2 divided by n1 plus n2. Now, by doing a cross multiplication, what do we get? We get, just a minute, we get 12,000. I mean, if I cross multiply, I will have 12,000 times n1 plus 12,000 times n2 is equal to 10,000 times n1 plus 15,000 times n2. Now bring n1 terms this side, n2 terms this side. Means I will have now 12,000 times n1 minus 10,000 times n1 is equal to 15,000 times n2 minus 12,000 times n2. I took this term to the other side. I took this term to the other side. So what do I get now? I get 2000 times n1 is equal to 3000 times n2. Or dividing both sides by 1000, I can simply write it as 2n1 equal to 3n2. Now, I can say n1 is 3n2 by 2. Taking this 2 this side, this 2 if I take it that side, it will become 3 by 2. Or I can write it as 1.5 n2. Means I can convert n1 in terms of n2. What is our interest? Our interest is to find out this percentage of skilled workers. So therefore, percentage of skilled workers is equal to n2 divided by n1 plus n2 multiplied by 100. So what is that? n2. I will write it as n2 only divided by n1. We know n1 in terms of n2 is 1.5. So 1.5 times n2 plus n2 into 100. Now I can write it as n2 divided by, here in the denominator the common is n2. Let me take it outside. So you will have 1.5 plus 1 here into 100. I can cancel this n2 and n2. 100 by 2.5. How much it is? 40%. So that is the solution for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends and also subscribe to my channel. Thank you.